For For those of you who are new to the series, then we've been doing this since January. My name is Dr. Rumi Begum. I'm a senior lecturer in nutrition and exercise science at the University of Westminster in London. I also am the events manager in SAWHE. So as part of my role, one of the first things that I was asked to do was put together this researcher series. And today I'll be sharing the session or co-chairing this session with Jahnara Mia. To let you know, as always, our intention is to keep these very light sessions so that we can hear about all the researchers, the wonderful researchers in the South Asian community, and to really kind of connect if it aligns with our own interests, but also to have this space where we can share our progress, our work, and the fantastic research that's happening across UK universities. We obviously always encourage new connections. So in this chat, please feel free to add your comments, have questions, etc. Use your microphone towards the latter part of this talk if you would like to ask any questions. But we keep it very light. So without any further delays, I'm going to pass over to my co-host, Jahnara, who will introduce our guest today.
Great, thank you, Rumi. So good morning, everyone. Yeah, I'm Jahnara Mia, so I'm a research associate at University of Manchester, and I'm also the Bangladesh lead for SAWHE Network, and I'll be co-chairing this session with Rumi today. A very warm welcome to our seventh speaker of this researcher series, Soumya Sharma from University of Westminster. So Soumya is an international PhD researcher at University of Westminster, and she's very passionate about sustainability and innovation, and which is really important, especially in this kind of current climate of how things are. And she currently serves as a project manager at Cavendish Living Lab. So she holds a degree in biotechnology, biochemistry, and genetics from Garden City University in India. And previously, she's worked as a junior research associate at Taurus Biosciences. There's a lot there, Soumya. And she's also leading a project in microbial research, waste decomposition, and sustainable solutions such as mycelium-based packaging. And Soumya completed her kind of master's in applied biotechnology at the University of Westminster, focusing specifically on kind of bio indigo production, and was awarded the Westminster Employability Award. So many congratulations on that. And her current research explores antiviral and antimicrobial coatings, aiming to bridge that kind of science with real world impact for a more sustainable future. And it all sounds amazing. So I'm really excited to hear more about this. So yeah, over to you, Soumya. Tell us more. Thank you.
Thank you so much. It was really nice. Thank you so much, first of all, for the opportunity for me to deliver a talk. This is really great platform. And I have always been interested in where I see women. I have worked throughout with females, and I get really excited when I see the females in the higher education and even the CEO positions. I'll talk it through more, like how I've worked with different companies and which had the CEOs who are females, and that motivated me even more. And they are still my mentors throughout to date, and they all were South Asians. I'll share my presentation.
Coming through, something's coming through. Thank you.
Yeah, is it? Can you all see it's on the presentation mode?
Yes, we can.
Yes.
Thank you.
Okay. So today I wanted to talk about the hidden pandemic and how our nature can help us fight this hidden pandemic, which is basically antimicrobial resistance. You all have already heard about my journey, but I'll just tell you a little bit about it. So I started my undergrad in 2017, and I did my major and genetics. And in 2019, I started working as a research intern in a place called Series-Session7. So this company is run by a female CEO. Her name is Dr. Sashi, and till date, she is my mentor as well. And that's how I got introduced to the term sustainability. I understood how important it is by working with them. And then in 2020, I finished my undergrad and I started working as a junior research associate. It was the time when COVID was hitting us, and I worked on different projects with them. And my major focus was working on biofertilizers, farming, and sustainable development in biotechnology sector. Working with them for 2 years, then I thought this is the time I should progress in my education more, and I moved abroad, did my master's in applied biotech here at University of Westminster. And that's when I started working as an urban food grower with Cavendish Living Lab. So Cavendish Living Lab is a project which is led by students, and it's a sustainability based, treating University of Westminster campus as a testing bed, and giving an open opportunity to the students to explore and work towards sustainability. Since 2022, I have served different roles with the Cavendish Living Lab, and currently I work as a project manager and I'm managing the entire project. In 2023, as I was finishing my master's, I started my PhD, and I met my PhD uh, director of studies through Cavendish Living Lab. She's also a South Asian woman who runs that project. And when I was working with Cav Lab, I was like, oh, I'm really interested how we are putting biotechnology and sustainability together and doing this amazing work. I want to do it as a researcher and take it more seriously, one step ahead. That's when we both decided, and I started my PhD with her, and I got funded by a School of Life Sciences at University of Westminster. And currently, I still work with Cavendish Living Lab as a project manager. And I also have taken up a role as a digital research champion in a project which is called Step Up. This project is in collaboration with King's, UCL, and Imperial and Westminster, four universities working together in promoting digital research to all the PhDs, to all the early career researchers. And this is all about my research background. So I'll just start the talk of the day. So why I chose antimicrobial resistance or a hidden pandemic. When I was starting my PhD, I got a chance to do a 3-minute thesis competition. And before I could start my PhD, I did that. And I understood my project more in depth when I was prepping. How should I do? What should I answer? Why I want to do that? Why coatings? How will it link to it? That's when I was like, yes, I want to deal with something which is bigger. So in 2019, UK Health Security said the next hidden pandemic after COVID will be antimicrobial resistance, and it's initially growing. We all are not aware of it. So for who don't know what antimicrobial resistance is, so it is basically the capacity of microorganisms, or you can say them as little bugs, which causes diseases. They're getting resistant to the drugs which are meant to kill them, which are basically antibiotics or antimicrobial drugs. So those drugs are no more working against them. That is known as antimicrobial resistance, and this is a next hidden pandemic. And there have been estimated 1.27 million deaths which were caused in 2019, and it has been increasing every year. And according to the data from UN, they said by 2050 we will have around 10 million deaths due to this, and it will be the major cause of deaths through in the world. And this is the right time that we have to take actions to prevent this. Now, why it's happening, or why it matters? Because all the treatments are failing. And we are seeing the longer waits in NHS because they keep you on the doses of antibiotics, and it is not working on us. We are being on antibiotic doses for weeks and weeks. There is long waits. The healthcare professionals don't know what to do because those drugs are not working on us. And there is also limited development of new antibiotics. It's been nearly 40 years since any new antibiotic was developed. The resistant infections are spreading even at a faster rate than we think. And it is also a threat to the modern medicine. So in November, I went through a surgery because antibiotics did not work. I had to get abscess removal because antibiotics were not working on my body, and I was put on antibiotics for a month. What it did to my body, only I know. And then I saw the patients in the NHS. There were hundreds of them like me. But it wouldn't have happened if I did not have the antimicrobial resistance. So I am talking about it, working on it, but I also suffered from the same thing myself in my personal life. Now, just one thing. What do you think is driving this antimicrobial resistance? If anyone wants to answer.
Is it overuse, Soumya, of antibiotics, or misuse maybe?
Yes. Okay, I'll just go. So there are many reasons which are driving this antimicrobial resistance. It's misuse for sure from the end of the patients, but it's also over-prescribing of these antibiotics, which are broad spectrum, and also inappropriate antibiotic prescribing as well. This might be the less cases in here, UK, but there are still the cases according to the data. But this is highly the case in other Asian countries as well, because there you go, you don't need even a prescription to buy antibiotics. So these cases are rising throughout the world, not only in UK. Also, there is poor sanitization techniques still. Even after COVID, we still see there is not proper sanitization everywhere. Another major reason is there is excessive use of these antibiotics in the agriculture. So the food we are consuming is already having the doses of antibiotics which are normal for us humans. So because we already have the normal dose of antibiotics in our diet, so the when we get the prescription, it's not working on our body because it is already in our system. So if we are getting a certain amount, it won't work. So they have to give us high doses. That is one of the major reasons of the antimicrobial resistance as well. The use of antibiotics in agriculture, in poultry farming, everywhere. So our food is having antibiotics at this stage. Now, how can we tackle it? So first of all is optimizing the prescribing practices. In UK, I know the UK Health Security Agency is already working towards it because I had a recently talk with somebody and they said they're working towards it. But in the other countries, I don't think so. This measure has been taken, and this is a big thing we have. Like to promote this in the other countries, they need to train their medical staff to prescribe it only when necessary. That's the biggest thing. Then development of new drugs, diagnostics, and treatments. That's where my research will come in, and that's where we will talk more about it. Then improve in professional education, training, and public engagement, promoting the responsible use of it, promoting the research and development, and improving the detection methods of the infections. So these are the few things that we can do as researchers from our end. So now that's how I started working on my PhD. So overall aim of my project was to develop the coatings, which will be derived from bioactive compounds from plants, and they will be sustainable antimicrobial and antiviral coatings, which can be used both in medical and non-medical field. Now, why coatings? Because when somebody gets a medical implant or prosthetics, they are put on the doses of antibiotics rather than consuming antibiotics orally. If we coat those prosthetics or medical implants with these coatings, they don't need to take it orally. That was my vision, that we don't have to consume it. If we coat the surfaces of the major equipments of the major surfaces with these coatings, we don't have to rely on orally or consuming the antibiotics. And to do that, since I wanted the entire project to be sustainable, not only the end product, so I wanted my entire story from the beginning of how I carry out my research to all the process of making it also to be sustainable and environmental friendly. So I focused on 5 SDG goals. It was good health and well-being, quality education, sustainable cities and communities, industry, innovation, and partnership goals. So to begin with, I thought, why not nature? Why don't we look around ourselves, because we have got cure to all the diseases according to lot of ancient medicine. We have the cure within us, like within our environment. So I thought, let me look into the plants. And why I thought of the plants? Because I read some research and some papers. They said if there are being studies being done when they are using plant-based any drugs, the these superbugs or these bacteria which causes diseases, their their ability to adapt or to become resistant reduces because they are coexisting with them in the nature already. So when we make a drug out of it, they don't become resistant as fast as they are becoming to these antibiotics. So that was my one of the reasons. It will be sustainable, it will be long lasting cure. So I picked up few plants. Initially I had 12 plants. Today I'm just showing a gist of my study, but I have 12 plants which I was growing in different environments, because I wanted to test again the sustainable growing method as well. The entire story I wanted to be sustainable. I started growing some of the plants within my university. There are some beds. I started growing them in the grow beds there in the soil. Then I had this indoor hydroponics unit in the lab, which I was using. This is a urban sustainable method of growing food or food growing anything medicinal plants. So I got that system and I started growing half of my plants in that, and I also got some plants commercially available, and I wanted to try all of them, will there be any difference or not. Then I have been telling about bioactive compounds. So these compounds are basically small chemical combinations which are already present in most of the foods we consume, and they are already present in lot of medicinal plants. And they have a lot of health benefits. We already have some of these bioactive compounds. You would have heard of curcumin in the market, which is helping us as a food supplements we consume, because these bioactive compounds have antimicrobial properties, antiviral properties, and also they prevent diseases like cancer and heart diseases as well. So the bioactive compounds which I was focusing on is a phytonutrients, and they are polyphenols and flavonoids majorly. For my research, I shortlisted only these two bioactive compounds, which I will focus and I will take it forward to make these coatings. So now the coatings. So I wanted to take these natural compounds from the plants and formulate that into a coating form. So these coatings will again be sustainable because I was focusing on biodegradable coatings, which will be PHA based polyhydroxyl alkanoids, and they are produced by bacteria. These bacteria are again living in nature around us, and they produce this amazing bioplastic which can be easily used for most of the applications. So I thought I will grow this bacteria which will produce the plastic for me, which will be coated, and I will incorporate my natural compound which I have got from the plants in it, and that is whole story. That is what I will be coating on the surfaces. And now moving on to how I started the process. I started extraction method from the plants. Now, even for the extraction process, I wanted it to be sustainable, and I wanted it to test with the traditional method. So I had two different methods in place. I started testing the traditional extraction method, which is widely used in the nutraceuticals, which is called maceration method. And then I had sustainable extraction method, which was ultrasonicated assisted method, which is a bit quicker, which is a faster method and is a very new method which is being implemented. I wanted to test both of them on all this range of plants. Along with the extraction process, there comes the solvents. These solvents are basically the liquids which you need when you are trying to extract these tiny compounds from the plants. So these solvents, which are usually used in the commercially available nutraceutical drugs, are ethanol, methanol, these ones, but they can be slightly toxic. That's why I wanted to test again the sustainable ones. That's when I decided I will work with something known as deputatic solvents. These solvents are made up of different combinations of organic solvents, and they are not at all harmful to the nature, and they can be potentially used to extract. That's what I read in some of the research studies. And I was like, I want to do the entire screening process of extraction of these methods, making it sustainable from day one of my research till the end product. So that entire process, it's not the only the delivery of my end product will be sustainable. No, we have to make the entire process sustainable for our nature, for our environment. And now I'll move on to my results, what I saw. So just to begin with, I'm into coating and apply these coatings on different surfaces. So I'm in my final phase of PhD, and this is my last bit of work left, which is formulation of these compounds, which has shown me positive results into coatings. So I designed the entire protocol to be sustainable from day one till the day end. Even for the formulation of coating, I'm going to use the techniques like 3D printing, which uses PLA basically already, and also the plastics which are reusable ones. And the layers of these 3D printed machine or the plastic which is there is made from the old plastic bottles or recycled plastic. So you use that to make another form of a coating. So this is something I want to implement again for my final step of my PhD. And finally, I would like to thank, first of all, the South Asian Women in Higher Education Network for inviting me, and this University of Westminster for funding my PhD, my amazing supervisory team. They have always been really, really open to me to go and explore anything I wanted. I started as a biotech person, but I think now I'm trained in even in microbiology, molecular biology, cell culture, everything, and they never said no to me. So that is what you need. You need a very supportive team. I also have an external collaborator. His name is Dr. Arya, who has been helping me majorly with testing my drugs or these things on antimicrobial resistant strains of the bacteria potentially. So I have that external partner and all the amazing team at University of Westminster academic technical team, my colleagues who have been helping me throughout. So I would like to thank them and thank you.
Oh, amazing. Thank you so much, Soumya. Brilliant talk. I'm just amazed.